Number 1. Which of the following is not a fundamental particle? So fundamental particle contains the family of leptons and the family of quarks. This family of quarks include the up quark, down quarks, strange quark, top quark, and the other two quarks. And the leptons, the family of leptons contain electron, electron neutrino, muon, muon neutrino, and tau, tau neutrino. So which of the following is not a fundamental particle? Electron is a fundamental particle since this. Neutrino is a fundamental particle because these are neutrinos, and pion is not a fundamental particle. Quark is a fundamental particle, which is this category. So the answer is C. Number 2. Which of the following could be a correct unit for magnetic flux density? So we have the formula, the force acting on a current carrying conductor, which is F equals to BIL, where B is the magnetic flux density, I is the current, L is the length of wire within the magnetic field, and F is the force. So we have to make the magnetic flux density the subjects. So B equals to F by IL. So B would be equals to F would be the unit for F, force is Newton. The unit of current is ampere and the unit of length is meter. So the answer is C. A toy airplane is being spun around on the edge of a piece of string. So we have a piece of string which is being spun around. Which of the following changes would require an increase in the tension in the string? So for example, this is the wire and this is the angle in which it is rotating. So the wire is rotating this way in this type of a motion. So the tension is T. So we can write that T sine theta equals to mv square by r, since T sine theta gives a horizontal component which is equal to the centripetal force, and T cos theta, which is the vertical component, gives mg, the weight. So equating these two, not equating, dividing 1 by 2, we would get T sine theta divided by 2 T cos theta would be mv square by r divided by mg. So we would get tan theta equals to, these m will cancel out, v square by rg. So we have tan theta equals to v square by rg. And we have another formula which we would need to solve this question, that is v equals to omega r. So number 3, which of the following would require an increase in the tension? So we have to increase the tension, decreasing the angular velocity. So when we decrease the angular velocity, the main velocity decreases. So when this velocity decreases, the velocity here decreases. So the tension decreases, it does not increase the tension. So decreasing the angular velocity would not cause an increase in tension. B, decreasing the mass of the toy airplane. So mass would not have any effect. Whether or not we increase the mass or decrease the mass, it would not have any effect, since the final equation does not have any m. The m gets cancelled out here. So B is not the answer. Decreasing the period of rotation of the toy airplane. So if we decrease the period, this means we are increasing the velocity. So increasing the period means we are increasing the angular velocity, so the velocity increases, and when the main velocity increases, the tension increases. So this change would have an increase in the string, so the answer is C. The next one is decreasing the speed of the toy airplane. Let me use another color. Decreasing the speed of the toy airplane. So if we decrease the velocity, that would lead to a decrease in velocity here, so the tension would decrease. So D would not also be the answer. So the answer is C. The toy airplane makes 14 full revolutions in 6 seconds. Which of the following gives angular velocity of the toy airplane in rads per second? So we have the formula V equals to omega r. V is the velocity, omega is the angular velocity, r is the radius. So we have to make the angular velocity the subject. So omega equals to V by r. So we have the formula angular velocity equals to 2 pi by t. 14 full revolutions mean that they cover 2 pi radians 14 times in 6 seconds. So the answer is B. Number 5. In the early 20th century, experiments were carried out to measure the scattering alpha particles after striking thin gold foil. Which of the following could not be concluded from the results of these experiments? A. The nucleus contains most of the mass of the atom. Yes, this is true since a few particles were deflected by large angles greater than 90 degrees. So the part A is correct. The nucleus is made of protons and neutrons. This is true but not proven directly from the experiment itself. So this may not be concluded since this might be true, but the experiment does not prove it. Part C, the nucleus is charged, right? The nucleus is charged, so there is deflection of the alpha particles. Part D, the nucleus has a much smaller radius than the radius of the atom. Yes, this is also right. So the answer is B. A kaon decays into a pion and two leptons. Which of the following decays is possible? So for all of these, first we need to consider the charge conservation. So this is 0, pion is -1, muon is +1, the electron, muon, neutrino is 0. So here the charge is conserved. For B, in the left side we have here -1, -1, -1 and 0. So in the left side we have -1 and in the right side we have -2. So the charge is not conserved. For C, in the left side we have kaon +1, pion is 0, muon is +1 and electron, neutrino is 0. So here the charge is conserved. Also in A the charge is conserved. For D, this is -1, this is 0, -1, 0. So here also the charge is also conserved. So the answer is either A, C or D. So we see that the electron is being released and muon, neutrino is being released. So for a decay, always, if electron is being released, then electron, neutrino would be released. When muon is released, then muon, neutrino will be released. So the answer is A. Since muon is being released, then muon, neutrino is released. So the pattern does not match in the rest. So the answer is A. But number 7. Carbon-14 is an isotope of carbon. Which row of the table correctly shows the number of neutrons and the number of protons in the nucleus of carbon-14? So the neutron number is equals to the neutron plus protons. And the neutron number is 14 equals to the neutron number we have to find out plus proton number is 6. Since in the carbon, this is a neutron, the nucleon number, and this is the proton number. So to find the nucleon number, we have to subtract 6 from 14. So the neutron number would be 8. So the answer is C. Number 8. In a linear accelerator, successive drift tubes increase in length. Which of the following is the correct reason for the increase in length? So to solve this question, we need to have our basics cleared. So for example, this is a metal plate where the electrons are released, and these are tubes which increase in length gradually. So a LINAC has a series of drift tubes like this, in which the electrons released from here passes through, and it is accelerated by the electric field that is applied. So in the LINAC, the length of tubes increases, as I have shown here. This is a particular reason. The polarity of the tube changes as the electron goes into a tube when it gets accelerated. So when the polarity doesn't change at the right time, then the electron may get repelled and the process would not take place correctly. So the rate at which the PD changes stays the same. This means that the time spent in each tube is the same, right? Since the frequency is the same, so the time period will also stay the same. Since F equals to 1 by time, if F is constant, T is constant. And another reason for the increase in the length is that we have speed equals to distance by time. So when the length of tube increases, since the distance increases, since the speed is increasing as it is accelerating, as the electron is accelerating,
this means the speed increase has to have an increase in distance covered so that the time period remains constant.
So let's see. Part A, the time spent by the particle in each successive tube increases. No, the time spent is constant. The time spent by the particles in successive tubes stays the same. Yes, this is correct. The particles gain more energy in successive tubes. This is also correct. The frequency of the accelerating voltage can be increased. No, the frequency remains the same. So statement C is correct, but it is not the correct reason for the increase in length, as I have shown here. So in part B, the time spent by the particles in successive tubes stays the same. Yes, this is correct, since I have told here that to keep the time spent in each tube constant, we need to increase the distance covered, since it is accelerating. C is also correct, but it is not related to the correct reason for the increase in length. So the answer is B. A ball of mass m with velocity v strikes a wall perpendicularly and bounces off the same speed in the opposite direction. So it has velocity v. strikes a wall perpendicularly and bounces off with the same speed in the opposite direction. Collision takes the time t. So the scenario is like this. This is the wall. It goes into the wall with velocity v. It bounces off in the opposite direction with the same velocity. As it is in the opposite direction and velocity is a vector quantity, the velocity here would be minus v. We also know that force equals to change in momentum by time. Change in momentum by time is mass into final velocity minus mass into initial velocity by time. Mass into final velocity is this, minus v. So mass into minus v minus mass into initial velocity, which is v, divided by time. So minus mv by t. So it would be minus 2 mv by t. So the answer to this question is D. A proton P and an electron E with the same velocity enters a magnetic field which is perpendicular to the direction of motion. The field acts into the page. So which of the following diagram best represents the motion of the particle? So the mark scheme says that the answer is C. Let's verify it by using Fleming's left-hand rule. So let's verify it by using the Fleming's left-hand rule. So by Fleming's left-hand rule, let's consider the electron at the point. Let's assume the point is x. So at point x, the electron is moving rightwards. So if the electron is moving rightwards, the conventional current would be leftwards. So the middle finger would be pointing leftwards, and since it is the current, the conventional current, and since it is given that the field is acting into the page, the direction of our index finger would be into the page. And by that, if we do that, we will see that the thumb will be pointing downwards in this direction. And that is true since the force is being exerted downwards, so the electron is moving downwards. Same thing can be proven with this proton. So the proton is moving upwards, so the conventional current would also act upwards. So if the conventional current is upwards, then the middle finger would be acting upwards, and the magnetic field line is acting into the page. So the index finger would be in the direction into the page, and by that we will see that our thumb will be facing leftwards. So as we can see here, the proton is actually moving leftwards. So in this way we can prove that the answer is C.